Programming Throwdown, Episode 70, COBOL and Mainframes. Take it away, Jason.
Hey, everyone. We get a lot of emails of people saying, hey, can you advertise, our new, energy drink or something? We didn't actually get an energy drink. I just don't want to call anyone out. And we don't, everything we advertise, or everything we talk about, I should say, are things we legitimately use. We don't just, I think the word is shill. We don't just shill for people. As kind of part of proving that, I was on Udacity because I was interested in game theory plus reinforcement learning. So for people who don't know, I did my PhD in reinforcement learning, and I've also been just really fascinated with game theory. And now those two things are actually starting to come together. So game theory has advanced to the point where economists don't know what to do. And we'll talk about that a little bit. And reinforcement learning has gotten to the point where machine learning engineers are kind of stuck, and they actually come right together. And they're both kind of on this crash course. So I put that into YouTube just to kind of see, what I would get, what people are thinking about that. And I got a Udacity course. It was actually the last video in the machine learning course was the first result. And basically, it was Michael Littman, who's pretty famous in the reinforcement learning community. And he's like, yeah, we don't know how to solve this. He's like, here's some ideas, but I have no idea. So it didn't really help me that much. Actually, the ideas were some pretty good leads. But it was pretty cool that Udacity is pretty integrated in YouTube and all of that. But basically, just to kind of fill everyone in, so, when you think about game theory, you think about sort of these two-player zero-sum games. For example, or maybe not always zero-sum, but, for one person to win, the other has to lose. And so, for example, there's this game called Matching Pennies. Actually, Matching Pennies isn't zero-sum. There's Prisoner's Dilemma is one. Prisoner's Dilemma also isn't zero-sum, but this idea where there's these two people, and if they both get put in two separate rooms, and some investigate. Imagine you and a friend commit some crime together, and they put you in two separate rooms, and they say, okay, you need to confess, and if you confess, then we're going to give you less time in jail. If you don't confess and we find you guilty, you're going to get hammered, right? So if you confess, let's say Patrick and I are in this situation, we rob a bank or something, we get busted, we're in two separate cells, and I say, yep, I did it. And Patrick says, yep, Jason did it. Then I'm in big trouble. I'm going to take I'm going to be the perpetrator, and I'm going to be the instigator, and I'm going to get this huge sentence, and Patrick's going to go free, right? And vice versa, right? If we both say, yeah, we did it, then we'll get a little bit of a sentence. We'll get a reduced sentence for being honest. And if we both say none of us had anything to do with it, then the police have no evidence, and we get off, let's say, scot-free. That's the best, right? We might go to jail for a little bit. We might have a long interrogation, but at the end of the day, they let us go. So that's the best, but it's hard to get there because it's hard for us to trust each other. If I say, the best is for us both to say we did it, and then we both get a reduced sentence. If we both say we didn't do it, then we both get, pretty long sentence. So we both want to say we did it. Right, we both want to say we committed the crime together, and then we kind of we'll both get some punishment, but not that big a punishment because we admitted it, right? But the danger is if I say, yeah, I did it, hoping that Patrick's going to do the same, Patrick could just say, I didn't do it, and I get the full sentence. So if Patrick knows that I'm admitting guilt, if he knew that, then he would obviously just say I didn't do it, and he would get off, right? And so game theory, that's kind of one example of one of these complicated situations, right? If you don't have any communication with the other person, then you have to just deeply trust them, or you just say, I didn't do it, and hope that they do the same thing. or not do the same thing, but just it puts you in what's called a Nash equilibrium, which just means that if I say I didn't do it, then that's and Patrick says he didn't do it. That's sort of the best we can do with no information. Anyways, it's a little bit kind of, it's a complicated subject. There's a lot of super interesting work on it. But then there's this question of what happens when you have 3 players. And it turns out when you have 3 players or a non-zero sum game like that Prisoner's Dilemma, things get really, really, really complicated. It's almost as if, think of it like this, pretend like you didn't know what a for loop was. And so you're writing you have to sort 10 numbers. And you actually do it by writing all the instructions. You do a bubble sort, literally all the instructions, like an unrolled for loop, because you don't know what a for loop is. And then all of a sudden they say, okay, now you have to sort 10,000 numbers, right? Without a for loop. You're kind of in trouble, right? And that's kind of where economists are with, multiplayer game theory, is they think about things at this kind of level of detail, but it's hard to sort of abstract that, and it's hard to scale that out, let's say, right? On the other side of the fence, there's reinforcement learning, where they can easily handle huge games. You could play chess, or you could play Go, or you could play one of these games where there's just millions and millions of different ways the game could be played, and it still works. But reinforcement learning only works on 2-player zero-sum games. Go is an example. There's 2 people, and then at the end of Go, one person wins and the other person loses. There's no in between. You can't both win or anything like that. And so as soon as you go to a 3-player game, or something like Prisoner's Dilemma, where both people could win if they choose certain strategies, reinforcement learning doesn't really know what to do there. And so there's sort of this sweet spot where when you have these kind of complicated games, imagine a 3-player game of Go or something like that. Nobody really knows how to solve that. The game theory people can't scale up, and the reinforcement learning people don't know how to handle 3 players. And so it's just this hole. And this is something kind of super fascinating, and I've been kind of really diving deep on it. It's just, I think it's kind of amazing that so many kind of research papers are out in the open now. You don't have to I don't know, Patrick, do you remember this when you had to subscribe to Science Direct, or you had to use a login from the university library to read research papers?
I didn't do it often, but yes, I do remember when it was much harder to get stuff.
Yeah, I was buy this research paper for $50. That was curated with government money. It's they finally kind of stopped a lot of that. And so it's pretty awesome that between Udacity, YouTube, free and open research papers, that, you can dive deep on almost any topic. And that's sort of what I'm binging on right now. Did you take any game theory courses, or any was it part of microeconomics or anything like that?
I'm sure it was talked about in some economics course, but I never, I was always sort of self-learning, reading about it. It isn't talked about that much.
Yeah, same here. I mean, I had a game theory course in grad school, but other than that, I kind of elected to take that. But yeah, in general, it's a topic that is actually super interesting. Anytime you have any type of negotiation, or there's an auction, you're on eBay buying something, there's game theory, at play there. One kind of really interesting game theory problem is called the Keynesian beauty contest. Have you heard of this? I think were you the one who told me about this?
I might have.
No?
Is this the one where everyone votes on who is the prettiest person, and you get a chance of winning if you voted for the person who ended up being the prettiest person?
Close. So the way it works is, I think you have the right idea, but it's not the prettiest. It's actually the person in the middle. So everyone picks a number between 1 and, let's say, 100. And if you get the median, you get $1,000. So so there's going to be some people who will call them level 0 people. These are people who are just going to pick a random number. They're not going to really know what to do, right? And so let's assume that everyone's a level 0 person. Everyone's just picking random numbers from 1 to 100. and you want to pick the median. Well, you're going to pick, 50, right? Because there's going to be a whole, range of numbers, and you're going to pick the one in the middle. But there's going to be some people who are going to think the same way that you just did. So there's going to be a group of people who are all going to pick 50. And what that's going to do is that's going to, make the middle go lower, right? So if there's it can't be 50. Let's say it's the bottom 1/3 or something. So a bunch of people are going to pick 33. And that's going to make the middle kind of go lower, which is going to make the median go lower, which means if everyone, for example, if half the people pick 33 and half the people pick just any number, then you want to pick something less, like I think it's like 25 or something. You can calculate what it is. But then you can keep kind of doing this. You can keep saying, oh, there's going to be some people who are going to think 2 steps ahead, and so I should think 3 steps ahead, or I should try and figure out how many people are going to think 2 steps ahead. And yeah, this whole stuff is super fascinating. And it turns out whenever you're dealing with like auctions or these type of like financial negotiations, the stock market, stuff like that, all of it has sort of the game theory kind of built in. Like there's agents who are, calculating all of this. There's all the quantitative trading is based on this. And it's definitely worth checking out. I'm going to post a link to the YouTube video, the Audacity, that part of not the end of the course where I went, but the part that starts talking about game theory. And it's actually Michael Littman, who is a super genius, and another gentleman who I don't remember his name, but he's actually a pure economist. And the two of them together talk about game theory and reinforcement learning. And then together they just hypothesize what to do, now that they've crashed into each other. So yeah, check it out.
I think for game theory, one of the things for me is, this doesn't exactly fall into the economic standpoint, but understanding that each actor in some situation that you might encounter in work or life or whatever has a different perspective they're viewing, and they're trying to make their own decisions based on what you're doing, just like you're trying to make a decision based on what they're doing.
Yeah, actually, you hit the nail on the head. So like the current like best idea for solving this problem, where let's say you have like a good example of this is there's this game called Dota, Defense of the Ancients, and it's a 5 versus 5 game on the computer, and there's people who are trying to have an AI play that game. But you could imagine AI robots playing soccer or AI people really playing any type of team game like Counter-Strike or Team Fortress or something. None of these AIs are really any good because they can't really cooperate. And it turns out the way to sort of get the cooperation and the multiplayer is there's a technique now called neural fictitious self-play, which sounds kind of weird, but basically it's as you said, you are trying to do what's best for you, but you also keep a mental model of all your opponents, and you play the best response to what you expect them to do. So, for example, if there's this amazing chess move, but you also know that your opponent has never played that move before, given that circumstance, then you're not going to plan for that. Like you're going to assume that he's going to miss it again, and you're going to play the best response to what you think he's going to do. And so it kind of gets into this Keynesian beauty contest where like, if you do that, but he's going to do this, and then it ends up being this sort of recursive thing. But yeah, that's kind of where the state of the art is right now, is in like this opponent modeling and all that.
Makes sense. I wish I had a more I should probably become more academically rigorous about my understanding of game theory, but maybe it would help or maybe it wouldn't. I'm not sure. Like as far as like a practical day-to-day life, like you talked previously, you recommended a book on sort of negotiation, and it's clear how that applies day to day. Do you think studying more game theory, studying more game theory in an academic sense, past, sort of a peripheral, superficial understanding, do you think that has benefits to like how actually stuff happens out in society?
I think the high level concepts, yes. So in other words, this idea that, there's going to be like some group of people who are going to think one step ahead, some are going to think 2, 3, 4 steps ahead. And that the interesting part is trying to figure out, what fraction of the population is going to think so many steps ahead. So then you can build sort of like the meta system. Like, I feel like that can translate into real life. So in other words, the very high level concepts where you don't need to, really understand a lot about information theory or anything, like the high level concepts, I would say yes. But they're also kind of like being developed as we speak. So no one has yet written like, a layman's guide to this stuff. So probably, unless you really want to geek out, it's probably not the type of thing like you'd probably be better off reading the negotiation book. But if you wanted to know, if you ever wondered like why things, remember I was talking about this earlier, like why things cost what they do. This is actually kind of just a continuation of that fascination. And so I think this is a big part of that. And so if you're interested in economics, maybe another way of putting it is, if you're a machine learning person, check this out, because there's this whole field of economics that you need to catch up on. And if you're an economist, it's exactly the same, but in reverse, right?
Fair enough.
So, yeah.
All right, on to the news.
Yeah, first news is a free book. So I was just...
Did you say free?
I did. Free. And it's not even a Keynesian beauty contest. Everyone gets it for free. Annotated algorithms in Python. So, I followed the programming subreddit, and I came across this. It's pretty cool. I skimmed through the book. It has a lot of really interesting stuff. It's similar to, I have a book from Sedgwick called Algorithms in C++ that I've had for, super long time. This is very similar in that it covers, a lot of the same algorithms. And it, the code is documented, and there's also, paragraphs describing the solutions, right? In general, I think Python's a better language for kind of explaining things. So this is probably a better book than the one I have, and it didn't cost $100. It's totally free. So check it out. You can get a PDF of it. It's a long book. I mean, when they say it's a full book, it is 388 pages. So it's the real deal. You could probably get a physical copy. I don't know how much that would cost, but it would be worth grabbing one of those. Otherwise, feel free to thumb through the PDF. It's totally free.
Nice. My link is... this is terrible, I guess, this is not really a news story. But this, if you type in interactive bloom filter, maybe Google can do it. Otherwise, the link will be in the show notes. But this is a little... Well, you wouldn't call them a widget anymore, like a applet. But and this is a JavaScript application demonstrating how a bloom filter works. Okay. But I thought it was two things. One, an interesting opportunity to mention to people about bloom filters. And a second thing, I thought it was a pretty good thing. So this is one at a website, Jason Davies, presumably by a person named Jason Davies.
You're right.
And if you search interactive bloom filter, it'll come up on Google. I think the second hit for me. Otherwise, the link is in the show notes. And what a bloom filter is if you think of a hash map, which is you have some array, and you take some object that you want to put in the array, and you hash it in some way, and you put the object at the index in the array that was the result of your hash function. So if you've never heard of hashing before, that probably made no sense. And if you've never heard of hash maps before, it was probably not a great explanation. But essentially, you have a big list of places in your array, and you put an object in somewhere in that list. And then there are ways of handling things like collisions. Like what happens if two things can hash to the same result, especially if you imagine having only like two elements in your array. Even if you have a really great hash function, you still only have two results. So you're sort of modulusing whatever your result is down to only two. And so your chance of collision, if you have one object in, is 50%. And so what happens is that as the table gets more and more full, you have to grow it because you need to make sure these collisions don't happen because they degrade your performance. And you limit how much stuff you can hold in memory. So what if you want...
I see. So I've never seen a Bloom filter before, so I might totally be embarrassing myself here.
Yep.
But I think the idea, correct me if I'm wrong, is that you don't need to like actually look up a value. So the difference between a Bloom filter and a hash map is a hash map.
But don't spoil it. No, don't spoil it.
Oh, okay. Sorry. I'm just figuring it out now, so I'll let you finish.
Okay. Sorry. Not to interrupt you. But to interrupt you. So if you imagine you're building this hash map, a lot of people have done this, and this is great because it provides constant time lookup of your object, right? So now imagine if you had, a bunch of records in a database, and say there was way too many to fit in memory, but you still wanted to somehow keep track of which things were in your database so that you didn't have to perform the expensive database lookup just to see if something with a given ID exists. And Bloom filters are the solution to that, or a solution to that, which is to say, if you have, maybe you have, 100 million potential objects in your database and you don't know which ones, and it's, cost you seconds to go over the network or to go to disk to read them out of the database, you're stuck with this simultaneous problem of it's expensive to check and it's too big to just hold all of the values in memory. And what a Bloom filter does is take the items that are stored in your database, hash them, not once, but in 3 different ways. And there's, kind of different ways of producing 3 different hashes or however many different hashes, but producing multiple hashes, and then setting a Boolean flag in a big hash map that's just a Boolean saying true or false. And you just start hashing all of the items that exist on your disk. And you just hash them into this hash map. And what happens is you will get collisions, or, it's very probable you get collisions, but you're not worried about it. When someone comes in to ask a question of the thing that I guess this is sort of like a cache, hey, do you have object foo? You hash object foo. And if you have trues in the hash map for the 3 hashes of foo, then what you can say is maybe. But if you don't have 3 matching, or in this case, 3 is the example they have here in this demo, so I'm saying 3, but it doesn't have to be 3. But say you've hashed foo 3 different ways and it didn't match. You don't have those 3 entries. And in fact, as long as if you're missing any one of them in your Bloom filter, then you go, oh, actually, I know for certain I don't have that there. Because if you did have it, you would have those 3 entries in your Boolean map. And the reason you can only say maybe if they're there is because you could have had collisions from multiple other different features that produce those entries in the hash map. And so you don't know for sure, but based on the parameters of the hash map, sort of how many collisions happen, how many of the entries have the Boolean flag set, you can, sort of a priori up front, you can know how likely, if you say yes, is it to be true. And
yeah, I see this.
The more willing you are,
that's awesome.
The more willing you are to accept false positives, the more compact your Bloom filter can be, the smaller memory footprint you need. If you want it to be... Yep, sorry, go ahead.
Oh, yeah, so the Bloom filter in the example here is what, like a thing size of like 50 or something?
Yeah, I would have to count it, but on that order, yeah.
So basically, I put in just 3 words. I put cat, dog, and dart. And then I just asked whether A was there. And it said no, because A hashed to 3 completely different cells than any of those words. And I said AA, and I said AAA, and by AAA there was like 1 collision, but then the other 3 were empty. So it knew that AA couldn't be there. And then I kept going and going and going. I don't even know how many A's I'm up to, probably 100 or 50 A's or something. And it still has not even once been able to found one of these strings where all 3 of those cells are filled in. It's pretty amazing.
Right. So you can find, of course there exist bad cases. So if you're talking about I'm not going to get into the academic definition, but if you're talking about like non-random queries, like your queries have patterns, like this can be much worse. But for just sort of like, because you could get a collision on your very first try. So if you imagine sort of cat and dog happen to hash to the same 3 values, then you're just screwed, right? Even though you only tried twice, that can happen. Just the probability of it happening is low.
Yeah, I mean, if you, like, assuming nothing about the hash function, right? Like, yeah, the probability of that happening is, let's say there's 50 cells, then it's 47, 1 over 47 times 46 or something like that. But yeah, it's extremely low.
But the more you'll notice if you play, so everybody should check this out. So if you don't know about bloom filters, I've never had the opportunity to use one before, but I always sort of keep them in the back of my mind that like this would definitely be helpful if you ever needed it.
Yeah, this seems awesome.
And if you sort of play with the example, what you'll learn is the more things you put in the hash map, the more collisions you get, the more likely it is that when you query it, you'll get back a probably there.
This is one of these things like, I always am fascinated with just how unbelievably fast databases are. And this is probably one of the techniques that they use, right?
I mean, it can be used for lots of things. Like I've seen it used, a lot of distributed apps you can imagine want to do this kind of behavior because if you're making a request over the network, that's very expensive and a high latency. And so you'd much rather have it in memory, but you can't sort of hold all of the data in your memory. That doesn't work.
One thing I noticed, if you put in 13 Zs, it only points to one cell. I guess it's because the three different hashes all
have the same
thing.
Mm-hmm.
But I mean, that was something very specific.
But I think you could also, for things in which a collision is low cost, you could sort of also use this as your only data store. So like imagine saying like, don't want to pay a lot to keep track of all of the articles Jason has read on the New York Times, not a promotion for the New York Times website. But like every time that Jason has a cookie and I'm only allowed to store, I have no idea if this is how cookies work, but let's just invent a fictitious scenario for now.
Sure.
If I want to store that not in the cookie, but in the database backend for the New York Times, every time I saw Jason's IP address or his cookie key, like I want to only allocate 64 bytes to holding Jason's entry. Then every time he reads an article, I could take the URL of the article and put it in a bloom filter and just keep putting it in and putting it in. And over time, if I want to recommend him articles he's not yet read, I could consult the bloom filter and say, has Jason read this article yet? Yes or no? And if it says probably yes, it's not very expensive to me because if I exclude it from my list, it's really not a big deal. It's not a bank, right?
Yeah,
I'm just sort of like, but the great news is there are many, many, many visitors to the New York Times. And I sort of know that I don't have to pay a huge cost or figure out like, after a year, I should delete my users because up front you're saying for a very compact representation, I know I can hold this for all the users I'll ever encounter and know throughout all history, all articles they've ever visited without having to like phase stuff out of the cache or not or whatever,
Yeah, right.
And then
that's a great idea.
I think also,
in a sense, it's a little bit privacy preserving too, although, not quite.
I don't know that it's primarily used for that purpose, but yeah, you can kind of see that.
Yeah, I mean, it's a little bit more, it's more privacy preserving than just storing it in plain text. But yeah, it's probably not cryptographically safe or whatever.
Yeah. But and then you're right, also lots of databases like key value stores and things where you have some data in a cache in memory and some on disk, but you have to kick stuff out of the cache eventually, but you sort of hate to lose the fact that you knew that did exist. Yeah,
right. Yeah, this is super cool. Everyone should go to this URL. One thing I do include the show notes, when we post the update. So if you follow us on iTunes, the show notes should be in the, or on any podcast viewer, the show notes should be in the podcast notes. So you just tap the URL, and it'll take you straight to our show notes for that episode. And then you could tap this URL in the notes and go to the bloom filter. Everyone should check it out. It's really cool. Don't do it while you're driving, but if you're on a bus or something, or you're at home, when you get home, check out the this bloom filter JavaScript thing. It's pretty cool. My news, second news is Oh My ZSH, which is almost a tool of the show, but it's kind of weird making ZSH a tool, but Oh My ZSH is pretty awesome. Basically, I'm not like one of these people that really cares that much about, let's say, Bash versus ZSH versus C Shell. I feel like they're all more or less the same. But Oh My ZSH adds like a ton of functionality to ZSH. And I actually switched from Bash to ZSH just because of this. So someone that I used to work with showed this to me. It does so many cool things. Like the tab completion is incredibly clever. If you put, let's say, the middle 3 characters of a directory when you're doing ls and you hit tab, it'll figure it out. There's a bunch of like kind of nice to haves. Like when you're inside of a GitHub repository, it tells you what branch you're on in the prompt. It colors a bunch of things like ls and things like that automatically. It has a ton of really awesome features. Like another really good one is it has a bunch of different themes. So if you want kind of different color themes, if you want like a prompt that's pretty easy on the eyes, like a font color that's pretty easy on the eyes, and that theme will kind of percolate into like all the other commands, right? So when you do ls, it'll kind of fit that theme. So definitely check it out. The other thing is it'll do kind of this really cool tab completion. It'll actually, if you type in the name of a binary and then you do like -- tab, it'll actually run that binary with -- help, and then it will try to extract the command line parameters, and then it'll autocomplete. Or if you do, git -- what's the example? Or like git add -- b or something like that. It'll resolve that to branch or something, right? So it'll resolve command line parameters for you. It does all sorts of other cool stuff. I don't know if there's equivalents for other shells. Maybe there is, like an oh my bash or some equivalent, right? But I guess the high level thing here is check out these things. They're really powerful, and I feel like they've really increased my productivity like pretty significantly. So it's oh my ZSH is literally a one-liner. You have to change your default shell to ZSH, and then you run this one-line command, and boom, you have this whole thing. It also auto-updates, which is kind of dangerous when I think about it, but we got to kind of
Yeah, that does scare me. I do use it, but that also does scare me.
Yeah, I never really thought about the consequences there, but
I'm sure you can turn it off.
You have to trust that it's true. And then you have to trust that they know what they're doing otherwise. But yeah, I've been using it for a few months now, and I'm a big fan. It's pretty cool.
I guess I missed out because for news is something I came across, but it's actually a legit actual tool, but it's not a software tool. I don't know. Maybe I should have made a tool of the show. So this is the Curta calculator. So I came across this through a weird sequence of events. I had sort of known about it for a little while, like in the back of my head. I'd kind of seen it. And then there were simultaneously, I saw someone created a 3D printed version of this mechanical object.
Nice.
And then also Adam Savage, now that the guy from Mythbusters, they no longer do Mythbusters, has this channel on YouTube, Tested. And they covered this, the 3D printing thing that I had previously separately seen. The guy who 3D printed it printed one for Adam Savage that he unboxed on Tested.
Nice.
And so that reminded me about it. Anyways, so the Curta calculator is also known as, I think they call it the Peppermill calculator. And this is a non-electronic calculator. It just blows my mind thinking about it. And what you have is this tube that is maybe a couple inches in diameter. We probably should use metric, but I'm not, it's not at hand. Do you want to estimate the metric size of it, Jason?
Let me check.
Okay, anyways. So something that is roughly about handheld, and it looks sort of like a peppermill. And at the top, there's a little handle that you turn and grind just like you would.
It is about 5 centimeters in diameter.
Okay. And probably a little more than that long. And so what you have is a series of windows and displays, sliders and knobs that allow you to, on kind of one part of the tube, this is going to be horrible. You should check out the pictures. But one part of the tube, you sort of set, kind of like the input for your calculation. Then on the top, there's a set of displays that give you the output of your calculation. And then through a sequence of kind of throwing some switches and turning the grinder crank, you can perform multiplication, division, addition, and subtraction.
Whoa, cool.
On this calculator.
Can you buy one of these still or no?
No. They stopped making them when they basically got devastated by tiny little, pieces of silicon that did the same thing. So early electronic calculators with like sort of discrete components and presumably even vacuum tubes and stuff were very expensive and fragile. But then eventually you sort of had commoditized calculators, and it put a ruin to these beautiful objects.
Although these were popular all the way through the 1980s. That's surprising.
So check them out if you've never seen one before. I think they're quite expensive to buy in working condition, hundreds of dollars kind of thing. And it's just fascinating to me. And I don't think today we'd probably be like, ooh, this is terribly slow. But at the time, being able to multiply, I think it's like sort of 8-9 digit numbers with sort of 11 digit running sum was incredible.
Wow.
And to be able to do it pretty efficiently. And so if you've never seen one of these before, check it out. To me, as a computer scientist by trade, software engineer by trade, I'm always fascinated with intricate mechanical objects. And this is sort of some sort of pinnacle of mechanical complexity. All the moving pieces, the gears, the fact that you're doing this, we're going to talk about this. It sort of goes along with COBOL in a way, but doing decimal arithmetic, where you sort of have like the number 9 multiplied by the number 7, and you need to be able to do that and display it in several different windows that have essentially 10-sided disks that, pop into the right rotation when you, it's just crazy. It blows my mind.
Amazing.
Like, how do you even sit down and start to design something like this?
I think it's one of these things where like you really have to have a good background in like number theory. So actually I was playing a game. So just to recap, we did a few interview episodes, and that's why now we have probably 10 tools of the show all in one show. But I was playing this game called Human Resource Machine.
Yes.
Did you play this?
I have not. It's on my list of like, I should buy this and play it.
Just for people who haven't heard about this game, basically you're given an assembler with very few instructions, and you have to complete different tasks like sort a list or add 1 to every number that you can input. The thing about this really cool is if you have a background in CS, like if you have a bachelor's degree in CS even, you can blow through this game. Like you'll know everything. If people don't have a background in CS, it's really cool because it kind of walks you through how to do all of these things using just a very few instructions. And also it gives you an environment where there's a right answer. But then it's got these challenge modes. One of the challenge modes is do it in the fewest instructions possible. And that is really, really interesting. Another challenge mode is basically do it as quick as possible. So in other words, at runtime, you want to step through the fewest number of instructions. That's also really fun. But this is one of those things where if you have kind of a good background in number theory, you could probably figure out a way to do these multiplications using very few instructions. And I feel like that's kind of necessary when each instruction is like, a physical thing that has to happen.
I want to know how you just make all of the sheer number of meshing gears and cylinders and precisely engineered, and it looks like it still cranks rather easily. Like, that's crazy to me.
Yeah. Are you going to 3D print one?
So the 3D printed one is printed slightly bigger than the one. I really want to, but I've found that my appetite for 3D printing things with lots and lots of pieces is very low because I tend to get like halfway through. So I recently tried to print, this is off topic, but they have a 3D printable transmission model with different gear ratios. And so it's sort of like an automatic transmission, except it doesn't automatically switch gears. Oh, I guess just like a regular transmission, not an automatic transmission.
Oh, got it. Okay.
Anyways, and I was like, wow, this is amazing. So I like spent all this time printing it, suffered a couple, failed prints, but eventually got it out of print, and then realized I think it was not exactly square, my printer or something at the time. And so all the gears didn't mesh, and like I had spent all this time printing it, and then I think it wasn't quite right. And I didn't know exactly how to fix it. It wasn't obvious. And It was just really frustrating to have spent all that time, and then it wouldn't go together.
Yeah. That sounds terrible.
Yeah. So I would love to print this. Like in my mind, yes, I'll print this, but I know it'll probably never happen. I would print the first 3 or 4 things and then be like, oh, I see how this works. I don't want to print the rest.
Next. Cool. Yeah, maybe I'll give it a shot. I've been kind of itching for something to print, but yeah, I have a feeling it's
look at the assembly manual and sort of collaborate. For the 3D printed one, there's like a Thingiverse group or whatever where they discuss assembling it. I think there's only been a few other people to be able to do it besides the inventor. I think it's a pretty complicated thing. So check it out before committing to it.
Yeah, no. If it's not very simple to assemble, I generally am not very good at mechanical stuff. So
I mean, just look at the picture of how many parts there are inside of it. If you Google Curta calculator. Anyways, it's not going to be.
So I'm on Wikipedia, and it doesn't have a breakout of it, so I can't tell. It just looks complicated from the outside, though.
I'm sure if you search Curta calculator exploded, you will not want to print it anymore.
You will find a 3D printer on fire.
Yeah. Okay. Anyways.
All right. So yeah, we're falling a little bit behind, but we'll make this.
Okay. Here we go. We'll speed it up.
But
book of the show.
My book of the show is it's actually just a biography of Claude Shannon, who's a pretty famous mathematician, and I guess you could say computer scientist, although he was really kind of ahead of his time there. But yeah, check it out. I found this from a Medium blog that I follow, and the people who wrote the biography actually wrote a blog post talking about their process of because this is written posthumously, right? And so is that the right way to say it? Posthumously?
Not humorously. I think it's posthumously.
Posthumously. Anyway, so they after laughing, they decided to write this autobiography, and so they covered they actually went to his house. They did an unbelievable amount of research. Like, they're super passionate about Claude Shannon, these people, and they did a ton of research for years and years and years. I haven't actually read the autobiography. I just or the biography. I just got it. But just reading the blog post, I was already put it on my to-do list immediately, because it's an unbelievable effort. And the other thing is, Claude Shannon bucks the trend of sort of modern day success stories. They always say, modern day people are organized. Modern day people are always going to the gym. Modern day people are super hyper focused. And he kind of bucks all of that. Like, he's not focused at all. He also abandons ideas and then comes back to them 20 years later. And so this guy's like it sounds like he just has a limitless memory, and things are just incubating all the time, and it's just an incredibly uncertain environment. There's all of a sudden he's like, oh, something from 17 years ago now makes sense, and he just starts working on it, and it's just completely chaotic, totally risky, no plan. It just sounds it just completely goes against all. If you were to pick up a self-help book written by a CEO, this would go against everything. But yet this person was insanely successful, and I just find that fascinating. Also, as someone who's pretty disorganized, it kind of was sort of a ray of hope that people who are kind of cluttered and clutter-minded still have a chance. But it's just cool to see this person just go about life in a very different way. I mean, he'd invent a bicycle, a new type of bicycle, and then he'd create this new kind of math equation, and then so Claude Shannon's most famous thing is his work on entropy, which is that's kind of ironic, actually, now that I think about it. But it's he came up with information theory and entropy, and the idea that let's say you have a long string, but it's all A. That's actually pretty simple. And even if you add more A's, it doesn't necessarily really become more complex, right? That's a gross simplification of his work, but he covered a lot of these, what really is information, what is entropy, what is complexity, stuff like that. So yeah, check out this book, and it's not written for computer scientists, so so anyone should be able to pick it up and read it. And I'm looking forward to going through it.
His stuff comes up a lot in communication stuff. If you ever do networking.
Yep.
Yeah, you hear about his stuff. Fire Upon the Deep by Werner Vinge. I feel like I already talked about this book, but it's probably just because I read it a while ago and talked about it at work. So A Fire Upon the Deep is, I've had this recommended to me, numerous times by various people. It's been around for a while. I think it was written in the 90s. And so it's not a new science fiction book, but it is part of what ultimately became a series, although I've only read this first book. And I think it's decently well contained. And it is sort of sci-fi from the level of, very alien concepts. So, in fact, I actually had a little bit of trouble getting into the book initially. And just because of like how alien one of the sort of storylines in the book really is. I try not to spoil things, so I won't spoil it. But basically about people moving around in space and encountering alien species and some of the stuff that happens. And there's a lot of just like very strange things that happen. I sort of believe this is kind of funny because I've read several books between, but I had to pick one. But I think last time I talked about the 3-body problem, and similarly had this thing like this is very sort of strange and different. And this book had a similar feel that things just feel foreign in them. And it's sort of an interesting part of reading science fiction. And maybe this is what I read the most. Maybe other forms of fiction also have similar things, but just reading something that is talking about, putting you in sort of the perspective of an alien that has nothing to do with you. That's just so dissimilar from humans is obviously it's still.
That sounds like very tough to write.
Yeah, it is. And obviously like, sort of biased because fundamentally they have some form of communication because the author still has to describe it in some way and some pattern of thinking. And in reality, life could be very, very different than that in these stories, but it would be really hard to write from their perspective or whatever. Like writing from the perspective of a plant or a tree would be super tricky.
Yeah, right.
But anyway, blah, blah, blah. This is a side topic. This book is good. I probably wouldn't give it like 5 out of 5, but a solid 4 out of 5. This is a good read. I thought it was really nice. And I think a lot of people, this was a very important work to them. They really recommend it. So it's definitely worth reading. It's definitely not what I would say is sort of light reading. It wasn't easy to just sort of breeze through. It was sort of tough and crunchy to get through, but I enjoyed it.
So is this part of a series or no?
Yes, it is.
Oh, okay. Is the first one?
This is the first one, yeah. Cool. I don't know much more about the rest. So same thing as the 3-body problem is part of a series, but I'm not sure. This is always the tough thing about starting into series is you read the first book, but you're kind of signed up that you knew it was a series. You got to keep going because some of them just have like dramatic cliffhangers. Like they're really just one giant book split into 3 parts. Fortunately for the 3-body problem and this one, I don't really feel like that was the case. Like they didn't end on some giant, nothing is wrapped up. But you could tell sort of where the next books would go.
Yeah, that makes sense.
So you're not signing up to have to read the whole series if you don't want.
Yeah, that's great. This is a little bit off topic, but remember, well, just in general, I absolutely hate it when they set up like these huge cliffhanger endings. And especially when it's not great in the first place. And you kind of know that this series isn't really going to even survive. But then there's a cliffhanger, so you don't get the closure at the end anyway.
You're talking about like TV series.
Yeah. I was thinking about actually the Super Mario Brothers movie, watching that when I was like 8 years old. And I was like, even as an 8-year-old, I was like, this movie's kind of terrible. And then they were like Bowser ran away. It was like to be continued. And it's like, nope. Oh man. Well, so cool. So if you like those books, Claude Shannon, I'm actually reading, or I guess listening to on Audible. So you can get an Audible trial if you go to audibletrial.com/programming throwdown. And you could pick up the Claude Shannon book totally for free. And
also, The Fire Upon the Deep is on Audible.
Oh, nice. So
I say read, but I actually just listen to it. I just say read because it's too confusing.
I think I'm going to start doing that too. Yeah, I'm gonna.
Plus, like, it's sort of weird, but it's nobody's business that like it's the same if you read or listen to an audiobook. Like, and if you say I listened to this book, people are going to be like, "What?" And you have to explain it. If you just say I read this book, it's like, no.
Yeah, I agree. Yeah, I think it should just be
unless you say like I listened to, and it was like a magazine or something with pictures, like that would be weird. But
yeah, right.
For normal
right,
books, I'd just say read. You can also sponsor us on Patreon. The link is in the show notes, or search Programming Throwdown on Patreon. And thank you. A shout out to all those people. There's been an uptick in them, all the people sponsoring us on Patreon. So thank you for your continued support.
Yeah, it's getting close to Christmas. For Christmas, we take the money that's left over that we haven't spent on trying to grow the show or trying to maintain our server, stuff like that. And we give it in free t-shirts. Actually, we've gotten a decent amount of Patreon subscribers. So I think maybe what we'll do this year, we'll still give some t-shirts and then we'll give the rest to charity. So if you have a cool charity, send us an email or post on the comments or something like that.
I have my child's college fund.
the
Patrick's
the PW. The
progressive.
PWPW, the Patrick Wheeler Personal Wealth Fund.
Sorry, that is a joke. We will not be donating. No, that's not how that works.
We will not be donating to the PW squared.
Tool of the show.
Tool of the show. My tool of the show is
topic.
My tool of the show is BitChute, which is pretty cool actually. This is really fun. And it's using something called WebTorrent, which people should also check out. But BitChute is like YouTube, but there's not really any server. So the way it works is when you go to upload a video, you can choose to serve your own video or not, right? And then what happens is when someone goes to watch, let's say your video, they can actually get it from you or from anybody else who happens to be on BitChute and has a copy of your video. So as soon as one person watches your video, they then become a server as long as they're on the website. And so it's all done in JavaScript, like on the client side. So you're basically running BitTorrent, but on your browser. And if you go to WebTorrent, I think it's webtorrent.io or webtorrent.com, you can actually see a visualization of this. But even cooler, you just go to BitChute, and it just kind of feels like YouTube. But
it does not feel like YouTube. I just went.
What do you mean? Well, it feels like YouTube in the sense that there's a bunch of videos that you can watch.
Yes.
I don't know. I mean, and there's no search, I guess, is there?
No, but also just like the sort of like, I don't know, I guess maybe because I go to YouTube so much, it's now curated to my tastes. But I don't know what if you go to generic YouTube is. But the production value of generic front page YouTube videos is generally pretty good. Yeah,
actually, you hit the nail on the head. I should preface this by saying this is like
looks like cool stuff
technology.
people will get takedown notices from YouTube for.
Yeah, that's actually a really good point. This is like, I found this to be tool of the show because it's kind of a cool technology.
Okay.
I found it was cool that like functionally it's just like a bunch of videos, but it's like running off like maybe one machine on AWS or something. Like the idea that like there's not really a backend for this. But you're right. And I guess it's a tool in the sense that you could upload a video and give that link to a bunch of people and, I guess presumably it would work, although I guess your machine also has to be up. I don't know. Yeah, this is actually a terrible tool. My real tool of the show is Oh My ZSH, and this should be my news. But anyway, I just thought this was really cool. I mean, I didn't really think it was possible to have BitTorrent running in your browser. I thought that's like, I didn't really like. I don't even really understand. And maybe I'm definitely not a web developer, expert or anything. But I don't really understand how you can make connections to other people in the browser, like besides the server. I just figured like there was just a fundamental rule that like you could not do that. That seems like something that could be abused or something. But I mean, this is living proof that you can, not only can you do that, but these people have built like basically the functionality of YouTube without actually holding any of the videos, which is pretty wild.
We should also say we probably don't endorse any of the videos that are on this.
Oh, yeah.
Because most of these seem very conspiracy theory, like...
Actually, you know what here's what I'm going to do. In the show notes, I'm actually going to put WebTorrent and not this site.
Okay.
I actually know nothing about this site. I only was linked to it from WebTorrent.
I see.
So my new tool of the show is WebTorrent. You can go to webtorrent.io, and it actually, when you go to webtorrent.io, it starts playing a video, and you can actually, but on the left, you can actually see you connecting to these other random people and them actually giving you the video. So go there instead. But it's pretty wild, yeah.
All right, yeah. I mean, that is cool. That's crazy. Yeah, I just want to give that preface that like we can't vouch for the content on that website.
Yeah, I scrolled through some of it and it's pretty weird. So yeah, we're not going to make that up.
All right, my tool of the show is Gadget on iOS by Korg. Although I also saw they released this on Mac this week. Sorry, Android and Linux and Windows people. That's basically sorry, everyone. But this is, so also I have a warning, this is it is expensive, but it does go on sale. And for the kind of thing it is, like you can do, this is a music app where there's a bunch of synthesizers and a sequencer and tracks, and you can do, even audio recording if you want. There's really sort of like a powerful tool. And if you go and listen to some of the music people are producing on this app, it's just absolutely astonishing. But for me, I don't know, I have this weird, like I wish I was a musician, but I'm not.
Okay.
But I also don't have the discipline to teach myself an instrument.
Okay.
And so I like to play at being a musician. Like I have this idea, it would be cool to have like, a piano in the house, but then I'm going to have this giant piano and I don't know how to play. And I know I won't learn how to play. I'm a terrible person. Anyways.
Well, it's probably a huge learn. I mean, I'm the same way. I don't know any instruments, but I imagine it takes just an extraordinary amount of time to learn how to play something.
So I have tried. I mean, I took piano lessons when I was younger. And I ran into some problems that I just don't, like I didn't have good rhythm and I didn't sort of stay diligent enough, or, maybe if there had been YouTube, it would have been more engaging at the time. But anyways, doesn't matter. So this all started because I have this weird thing about synthesizers. I just love the way synthesizers work, and the way that I love the Curta calculator is this, mechanical object.
Oh, that makes sense.
These analog synthesizers, they're just these, boxes full of knobs and plugs, and especially if you don't know about modular synthesizers, specifically Eurorack modular synthesizers, check it out. There are basically these panels that mount on a wall, and you take 1/4-inch instrument jacks, sort of like fat headphone jacks, and you plug them in, between all these different modules. It's literally plug and play, and one, might make, random voltages going up and down, and another, has knobs for filter, and you have all these different things, and you end up making sounds, like weird sounds, cool sounds that sound like instruments, just all these various things. Anyways, I have this thing, and specifically, I wanted my tool of the show to be the Pocket Operator, which is by Teenage Engineering, which is something that is like a PCB that looks just like, and we talked about Curta calculators, so I guess it kind of goes with it, but it looks like a calculator, but it actually is this sort of toy, but also really cool synthesizer that is, it's still a little expensive for what it is, but, for these kinds of things, it's not very expensive. And it has these buttons that you push, and if you listen to the audio demos, it just makes these cool sounds. And it seems like something that people kind of just play with and make these cool sounds. I know if I play with it would be
kind of loop it or
terrible.
something.
That's right. Loop it and, make, change if it goes bloop or boop, and play sort of notes on it, all these different things. And they also make other things. This Teenage Engineering, check them out. But that couldn't be the tool of the show because it's a physical thing. And I wanted to have a piece of software. So I have this core gadget. You can play around on it, which is what I do, or make serious music. If you're into that kind of thing, check it out. It's kind of cool what people are doing. I actually have
the iCorg oscillator, which is a different app. It's probably a simpler version.
But very, very similar. Yeah.
Yeah, it's super fun. It was a little expensive. I think it was like $20 on the App Store, which is, a lot for an app.
Yes.
But yeah, I actually made some MP3s that it's like, again, like techno music made by someone who has no talent.
So it sounds good to you, and your mom would say, well, is that what you kids are into these days?
Yeah, exactly.
So similar to what my experience. I think this is $40, not on sale. Occasionally it goes on sale to $20. But yeah, I play around with it every so often, and pretend that I know how to make music, and it's cool.
Yeah, and you can actually save an MP3 and send it to your friends and stuff like that.
And I would never do that. But you might. I mean, if you make some awesome music, feel free to send it our way. I'm happy to listen to your music, which is probably better.
Yeah, let's have like a contest. Let's see, whoever makes the coolest MP3, and links it to us, like either SoundCloud or email us the MP3 or something. We can maybe make it the intro of the next show, or
at least the outro. Because if we get all terrible results, we'll pick the least terrible and put it as the outro.
We'll commit to it. We'll definitely make it something. We could probably make it the intro.
Some people out there have got to be good musicians. Someone's going to send us something awesome, and then I'm just going to feel terrible about myself.
No, if someone sends us something awesome, we will just replace our intro permanently. But we have a pretty cool intro. The Benar pilot is pretty awesome, so it's going to be tough to beat.
It's been good for 6 years.
Yeah, it's been going forever. But yeah, maybe it's time for a change. So yeah, someone send Send us some cool intro music and
change Programming
we'll play
Throwdown
it.
forever.
That's true. Yeah, leave your mark on the show.
All right.
Cool. After all that, COBOL.
Yeah, we're gonna have to go fast.
COBOL and mainframes. We'll kind of jump through this. So COBOL. So basically, COBOL is fascinating. It's used by so many people, even today. It actually started as an initiative through the Department of Defense and kind of a consortium of companies. And the reason to create COBOL was that, it was that time where people were sort of inventing a lot of languages, right? You kind of see this, actually, this has happened multiple times. And it's almost happening again right now, or maybe a couple of years ago, where remember how like all of a sudden we had TypeScript and we had CoffeeScript and we had like 10 different Clojure script. We had all these different ways to basically write JavaScript, or that would somehow transpile to JavaScript, right? So this is the same kind of thing. We had this, in the 60s, maybe even earlier in the 50s, you had this explosion of languages, right? I mean, there's Fortran 57. Lisp was coming out around that time. A ton of languages were being invented. And the issue is it was costing, the other thing is these languages were being built for specific machines. It's like, if you want to, use this machine, you have to write everything in, Fortran 57. And it's like, I wanted to buy the latest machine, but that machine requires me to write everything in Lisp. And it's like a huge undertaking, right? So these people got together and they decided to make sort of, they felt like if they got enough, all these big players at the time, like GE, Philips, IBM, and the government, Department of Defense, etc., that they would just make the ultimate programming language and it would be done. And people could just write in COBOL and they'd never have to rewrite it again. Obviously, that hypothesis was completely busted. In hindsight, you look at today, there's JavaScript, there's C++, there's, Java, there's Python. So this idea of one language to unify them all, didn't really pan out. But at the time, that was a perfectly rational hypothesis. It only makes sense in hindsight, right? That isn't the right thing to do. And so they made COBOL. To this, actually, as of 2012, which is the latest data I could get, over 60% of organizations are still dependent on COBOL to some degree, which is enormous. It means if you go and work for a company, let's say a large company, that it's more likely than not that you will have to see some COBOL.
Not that you will have to see, but that the company you're at
that's
has
true.
to.
Yeah. It's true. It's mainly used for, financial services. I know in a previous job, there was somebody who had to interface with, a credit card, company. So basically, let's say you have your credit card, it's Capital One, or you have a Chase card, you have the Amazon card, or what have you. There's a lot of different sort of, let's say, brands, but there's really 3 or 4 kind of, let's say, backends. So in other words, you might have a Capital One card, but it's really Visa, right? So there's someone who had to interface with, I think it was either Visa or MasterCard, one of these. And it was all in COBOL. Now, they had a specification. So, on our side, we didn't have to write COBOL. But looking at the specification, it was obvious that the people on the other side, that it was all COBOL. Everything was fixed with text and stuff like that. So it's columns 0 through 10 are going to be the name of the account and stuff like that. Another really kind of interesting footnote in COBOL is COBOL was ground zero for the Y2K problem. Now this was, I guess, 17 years ago. So there might be people listening to this. Actually, there's definitely people listening to the show who weren't even born when the Y2K problem was a problem.
Wow.
Yeah.
Dude, way to bring it home.
But for people who don't know or don't remember, in the year 2000, there was a big problem with computers, which is computers up until then, many of them had been using 2 digits to represent the date. So imagine, your bank. Every day they're calculating interest, and they're giving you, a fraction of a penny every day. And at some point, it becomes a penny, and you get an extra penny in your savings account, right? Now, all of a sudden, it goes from December 31st of 1999, or let's say 99, to January 1st of 00. So if you only use 2 digits to represent the day, what that means is you just went back 100 years back in time. And so that same bank that's giving you, you know, a tiny bit of a penny every day, all of a sudden they just drain your bank account. Like they're like, you know, you made, you know, negative half a penny of interest, you know, for, you know, 100 years. And so, you know, you had $500 in your bank account and it's gone, right? And so the Y2K problem was this belief that, you know, there's so many computers, all of them are using 2 digits for the year, that, you know, even if one of them isn't updated or some program isn't updated, it's just going to cause total havoc, right? And COBOL, because, you know, and we'll get to this, there's like, COBOL, like, you know, the number of decimals is kind of intrinsic to the language. And so many COBOL programs have been written assigning just 2 numbers for the year that COBOL was a big part of the Y2K problem, and it required a massive amount of work to, you know, get everyone on a 4-digit year in time. And the long story short, just to finish it off, you know, everyone fixed, all the major stuff was fixed. I don't honestly even know of one thing that went wrong that was in any way significant. That I remember. And, yeah, just basically nothing happened. But, you know, nothing happened because an extraordinary amount of effort went in, you know, before the year 2000 to make that fix.
So the basic functions of COBOL are that it has procedures, you do compile it as opposed to it being interpreted, and that it's statically typed for objects, but the primitives themselves are just duck types. So I mean, to be fair, I guess this set of things is not that much different from most of the languages we use today. But yeah.
Yeah, I mean, the only big difference is if you pass a number into a function that takes a string, it'll convert it to a string for you, and vice versa. That's kind of unique. But actually, can't really think of any language that does that.
Yeah, I guess that's true. Yeah, that's
yeah. Now that I think about it. So that is pretty special.
Feature or bug? You decide.
Yeah, it's true. I feel like actually that's probably more harm than good. But yeah, it's definitely unique. Another unique feature is this idea called picture clauses, which somehow like kind of combines classes with sprintf. So it's sort of like you basically say, you know, I want to take in a string and I want to, you know, kind of whenever a string enters this function, it comes out. Let's say formatted as a date. But instead of calling sprintf every time you want to do that, it's sort of this object that kind of holds the string, you know, in this new state for you. And it's kind of, you can kind of, you know, pass that sort of like this date converted string. You can pass that around to different functions and things like that. Yeah, I mean, currently, you know, COBOL is up to COBOL 2014. But, you know, the vast majority of the updates in COBOL have been to basically modernize it for the platform. So, like, for example, nowadays they're following the IEEE standard. So, you know, what happens if you divide by 0? What happens if you have 0 over 0, right? Like, how are
the
these
floating point
handled?
Mm-hmm.
Yeah, exactly. Like, all of that, you know, COBOL used to do its own thing. You know, I used to actually have a software, you know, floating point implementation, and they kind of scrapped all of that. Yeah, so it's a lot of like, you know, how do we run our COBOL code on, you know, a MacBook or something like that, or the latest, you know, Intel machine or something. That's been the majority of the changes. You know, a plurality of software managers said they're either moving off COBOL already, or they would if it was cheaper, but it's just too expensive to migrate all that code, which is kind of interesting. You know, I mean, if COBOL is any indicator of the future, you know, there's a lot of job security because you know, there's constantly things being written in different languages, and so you need that expertise forever, effectively. So yeah, I don't really know. I mean, what do you think, Patrick? Do you think that this is like a one-time thing because it happened when computers were so young, or do you think that this phenomena of always needing a COBOL engineer, that's going to happen for every language.
I think there's precedent for that being a thing. But I mean, for something like COBOL, there's enough people using it, enough lines of code written, enough support that support continues. A lot of projects will die off. So if you're writing in something, I'd hate to use an example, so I won't, but
I'll use an example, K. There's actually a language K that
okay.
So
at some point you get too few people using it. So unless your specific use is so valuable and impossible to get off of, basically you're not going to find someone who's going to maintain the compiler or maintain an OS. And even if you run an old compiler on an old OS, eventually your hardware is going to need replacing, and you're going to run out of people who make those kinds of processors anymore. So imagine like all of the systems that were like Apple computers used to run on Power PCs. At some point, your thing that was running on a Power PC that doesn't have an Intel-based compiler, an x86 compiler, that Power PC, you're going to pay more and more to get replacements, and eventually one day they're going to run out. You're not going to be able to get parts for your Power PC computer. And if your language never had an x86 compiler, you're faced with this like paying a vast sum of money to get someone, it's probably more expensive to get someone to port their compiler and to just rewrite your application at that point or whatever. So for things where there's not enough of an install base, I don't think you end up with this happening at sort of the at sort of the limit.
Right.
But for some things, there's enough of that's not true. Like, because for COBOL, maintaining the compiler makes a lot of sense because there's so many people using it. You're dividing up that resource cost amongst all of those people.
Yeah, it makes sense. I think for any language, let's say for any language we talked about in the show, except for that show we had on esoteric languages, but for all the other, 60 some odd languages we've covered, or maybe 50 some odd languages, I would say any of them will survive insofar as if you specialized in any of them, you'll be needed, let's say 20 years from now or something.
But the question is one of sort of, I guess, supply and demand, that if, so the specialists are still needed, but the question is like, is the team you're working on valuing that stuff? So if you're like the only, it's like the classic example, I guess, of, do you always hear, I don't know if this is actually true, but there's like 2 surviving Picasso paintings and some, person buys both and destroys one because one is worth much more than the 2 together.
Oh yeah. Marginal cost.
So if you sort of say that like you're the only COBOL expert in the whole entire world, you can probably charge a lot of money. But if there are lots of COBOL experts and it's maintenance, not new development, and so people sort of don't need that much work or don't value it that highly, and they're already sort of saying they're price sensitive is one of the reasons they're not moving off, then like the question is it lucrative enough for you to continue doing it? And that's a question each person has to make on their own.
Yeah, totally. Yeah, I think that's a good point. Like, if like, for example, like CoffeeScript was kind of a really big thing. Now, I mean, there's still people using CoffeeScript, but it's much less popular. And so, yeah, I think, as you said, it's a supply-demand thing. Like, if a bunch of people get super hyped about some language and then it falls off the face of the earth, that's kind of the worst because now there's so many people who are experts and not enough kind of work to do.
Yep. So COBOL often is, although it can be done on other stuff, often is used alongside of running the COBOL code on a mainframe. Oh, I said that poorly. Anyways, and so the idea here is we wanted to also briefly talk about mainframes, which is something we've not talked about before. And it's not something I personally have much experience with, although I have used them a couple times.
Oh, really? Wait, hang on. How have you used them? Because I've never even seen one.
I've not seen it. But so, I mean, I did intern at a company that did back-end banking software. And so all this stuff was run on mainframes. And so you had, I guess you'd call it a terminal emulator to the mainframe. Sure. And it's like very strange. And, it's something if you've never done before, it seems sort of weird. But just to go to high level so people sort of have some amount of background, this is by no means an in-depth covering of either of these topics, but about mainframes is that you want, sort of a single system that has very efficient throughput as a single system, but is also very reliable. So if you imagine instead of having like a distributed database, if you wanted to say, I want a machine that just has a very giant amount of RAM and a really fast processor, and I want to do things that's like every customer in my bank has a, entry in my ledger that's stored in this giant memory database. And I want to, give everyone the interest their account accrued each night. And so for each night, I want to go through all of my customers and, figure out how much interest they've earned, update their account. I want to do it. And this is where the batch comes in. I want to do it fast. So I'm doing it on a mainframe that's specialized for this kind of work. And I'm doing it batch processing, which sort of says, I want to do all of these things together, but I want each of them to be atomic. So if I sort of, get Jason's, bank account amount and calculate his, and for this, it's not important, but, calculate his interest, and then I want to update it. I want that to happen atomically. So in that case, you're only doing one thing, updating a single number. But if you were updating multiple things, you would want them to sort of all either happen or not happen in case of a problem. So that if you do run into an issue, you don't have someone's account left in a bad state, i.e., I was able to withdraw money and get cash out of the ATM and my bank account balance didn't go down.
Right.
And that would be bad because the bank lost money. That money disappeared and they don't know where it went. That would be horrible. And so they need systems that are reliable and a method of executing that, sort of also has this redundancy built in. And all computing used to be done on these, I guess mainframes was sort of like kind of the only way of doing things. And people would sort of timeshare on these mainframes and there would be jobs and each job would be executed and then the next one and then the next one. But now it's sort of different. It's often used in these, I want redundancy. I don't want redundancy in that two different computers are sort of both working on this task and, hopefully it'll work. Which is a lot of, like if I go to, we talked about before, like if you go to the New York Times and some part of it doesn't work, it's bad, but no one's like out tons of money or dying because of it.
Right.
But if you're in a bank, you really don't want to not know. And it is actually true that it's pretty difficult to coordinate across systems to get that reliability. Yeah,
you have to see this in the, you see that, remember that article of people who could figure out how to duplicate items in games? Like, there was this thing where someone would know sort of where the boundary of the zone is. Like it's not visible, but they just kind of know from the code. They're like, I'm in World of Warcraft zone A, but if I take one step over, I'm in zone B. And they would actually give an item to their friend and then just take this tiny step from zone A to zone B. And it would actually then end up with two items because the give command would fail in the second zone. But at the same time, it would pass in the first zone. And now there's two copies of that item.
Yeah.
And obviously, when you're dealing with real money, you can't do that.
Yeah.
So a mainframe would kind of avoid that.
And so, I mean, I'm not sure. Again, this is not my area of expertise. I don't hear of a lot of new development happening in sort of like great new features of mainframes. But I'm absolutely sure that tons and tons of new code gets written every year that work on mainframes. In this case. And also, one thing we haven't really talked on, and again, it is not really my background, but is report generation for the purposes of auditing, for the purposes of people to do overview, and not just in banking, actually in lots of different software engineering fields, report generation is very important. But mainframes and COBOL are two things that very specifically you want to roll up. Like, I want to know how much money is in a given branch of a bank, and I want to know how many current deposits do I have? How many, the accounting balance sheet, right? You want to be able to get reports of where every penny is and where it's coming from and where it's going to. And you need to generate those each night and check them for consistency, it be reliable and redundant and backed up, all of those things. I mean, a lot is at stake. And so that's the realm where you find these things.
Yeah, that makes sense. I mean, I think one of the things that really killed the mainframe is Paxos. So Paxos is this, I guess algorithm.
Oh, we do not have time.
Yeah, we can't cover it. We're already running super late. But it basically allows a lot of machines to coordinate. And I think we've actually talked about it in the past.
We have a consensus algorithm.
Yeah, if you search Paxos on our site, you could find it. If not, maybe we'll cover it in the next show. Send us an email if you want us to cover Paxos. But that I think that really is what killed the mainframe market, because all of a sudden now a group of computers could kind of do the same thing.
All right,
cool. So yeah, that's COBOL, mainframes, game theory, all sorts of cool stuff, algorithms in Python. So we had a lot of stuff to cover this episode. I hope you guys appreciate it. Sorry it went a little bit long, but we had a ton of content. It's been a long time. It's been almost 3 months since we had a non-interview show. So we had a lot we wanted to tell you about, and thank you again for all of your support. Looking forward to only a few months until Christmas. We start giving away some t-shirts. So if you haven't signed up on Patreon, go ahead and sign up. Even if you can only give $1, that's totally fine. You can give $1 and end up winning like a $20 t-shirt. It can happen. So thanks for all your support. Check out the books of the show, tool of the show, and send us all your feedback.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.